All right, given the following function, x cubed minus 5x squared minus 9x plus 45, we need to find all the possible rational zeros for this following function using the rational zero theorem. So the rational zero theorem says that p is understood to be my constant. So in this case, my constant is 45. Q is understood to be my leading coefficient, and the leading coefficient is, in this case, the coefficient on the x cubed, so it is 1. So what I'm going to do is I'm going to list all the factors of 45. So the factors of 45 are all the numbers that will go into 45 evenly. So when I list the factors, I do it kind of in an organized manner here. So 1 times 45 is 45. 3 times 15 is 45. 5 won't go into it. 5 times 9 is 45. 6 won't go into it. 7 won't go into it. 8 won't go into it. I've met at 9, so I know that these are all my factors of 45. 1, 3, 5, 9, 15, and 45. Then I'm going to list out my factors of my leading coefficient. So the factors of 1 is just simply 1. So finally what I'm going to do is I'm going to do plus or minus p divided by q. So I take every p value here and I divide it by every q value. So for this one, it's pretty straightforward here. It is plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 5 over 1, plus or minus 9 over 1, plus or minus 15 over 1, plus or minus 45 over 1. So according to the rational zero theorem, my possible rational zeros are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, and plus or minus 45. So the next thing that I'm going to do is I'm going to use synthetic division to test these possible rational zeros. So my function again was x cubed minus 5x squared minus 9x plus 45. Now it's important that we pay attention. We're not missing any terms here, so like it's going in descending order, third degree, second degree, first degree constant, so I'm not missing a term here. If I was missing a term, I'd have to fill in that missing term with a 0. So I'm going to, when I do my synthetic division, I'm going to set this up, and my leading coefficients are going to be just writing down the numbers in front of my variables here. So I have a 1, a negative 5, a negative 9, and a 45 here. So I'm going to randomly pick one of my zeros. So let's say I just do 1 for example here first. And what I want to know is if my remainder is 0. So when I do synthetic division, the first number comes straight down, and then I multiply outside number 1 here times this 1 is 1. Then I add, that's negative 4. Then I multiply, that's negative 4. Then I add, that's negative 13. Then I multiply, 1 times negative 13 is negative 13. Then I add here, 45 plus negative 13 is 32. That number represents my remainder. So that means that 1 is not a rational zero because my remainder is not 0. So let's see here. Let's pick 9, for example, this time. So now I'm going to put 9 in. So 1, negative 5, negative 9, 45. Again, the 1 comes straight down. So 9 times 1 is 9. I add, that's 4. I multiply, that's 36. Negative 9 plus 36 is what? 16 minus 9 is 7, 27. Then I add, then I multiply 9 times 27. Well, you can obviously hopefully tell that when I put that number up here, there's no way that this remainder is going to be 0. So I don't really have to do it, but we might as well finish this off. So if I take 27 times 9, that's 243, and I add 45 to that, that is 288, so my remainder is not 0. So I go back and guess again, So let's try positive 3 this time. So 1, negative 5, negative 9, 45. First number comes down, so 1 times 3 is 3. Add, that's negative 2. Multiply, that's negative 6. Add, that's negative 15. Multiply 3 times negative 15 is negative 45. This time I got a remainder of 0. That means that 0 is one of my rational zeros. Now, I could continue to do this and test my other possible rational zeros if I wanted to. So I could now try, for example, I could try 5. So I could go back to the original problem again, and I want 1, negative 5, negative 9, 45. And I bring down 1, so 1 times 5 is 5. Add, here I get 0. 5 times 0 is 0. Add, I get negative 9. Multiply, 5 times negative 9 is negative 45. Add, I get 0. So there's another remainder of 0. So 5 is another possible rational zero. This particular problem could have a possibility, it doesn't have to, it could have a possibility of 3 rational zeros because it's a third degree equation. The degree tells you the number of zeros that you're going to need to have. Because this particular problem already has 2 rational zeros, 3 and 5, it is probably going to have a third rational zero. So what I can do is I can go back to my list and I can see what the third rational zero is by guessing and checking again. So this time, let's see, we haven't checked any negative numbers here. So let's check negative 1. Okay, I'll go up here and do negative 1. So again, 1, negative 5, negative 9, 45. Bring down the 1, multiply, that's negative 1. Add, that's negative 6. Multiply negative 1 times negative 6 is 6. Add, that's negative 3. Multiply, that's positive 3. Remainder is 48. So negative 1 does not check. So I will tell you that I believe negative 3 is going to be the third rational zero. And so let me show you. Putting negative 3 in. 1, negative 5, negative 9, 45. Bring down the 1, that's negative 3. Add, you get negative 8. Multiply, you get 24. 24 plus negative 9 is 15. Multiply 15 times negative 3 is negative 45. Add, my remainder is 0. So that means negative 3 is another answer. So my possible, or my rational zeros, I shouldn't say possible anymore because these are my rational zeros. My rational zeros are 3, 5, and negative 3. That is where the graph should cross the x-axis.